Hi everyone. If Rocky has read 12 out of 24 books on his reading list, he's read 50% of his books. I hope you're all doing well and that you enjoy your time off from schoolwork next week. We miss you and look forward to seeing you soon. Bye.
Hey guys, Mrs. Maskiw has asked us teachers to solve some mental math problems with you and kind of explain our thinking as we go along. So I'm gonna solve the problem that I got today in two different ways to see if that helps any of you with your learning. So the problem that I got was 3/4 times 12. So to me, this means that we are trying to figure out 3/4 or 75% of 12. I'm going to work with it in fraction though. So because I have a fraction and a whole number, I want to make both numbers into fractions. So I've got 3/4 over here, and I've got 12 over 12 over here. That makes one whole, right? Now I need to find the lowest common denominator. Now 4 and 12, the lowest common denominator is 12. So I want to now convert my 3/4 into a fraction of 12, or out of 12. Okay, so 4 times 3 equals 12. And what I do on the bottom, I do on the top as well. So 3 times 3 is 9. So therefore I know that 3/4 or 3/4 of 12 is 9. Or 3/4 times 12, I guess, is 9. The second method that I would use is actually like using a number line, or you can use like manipulatives or anything that you have. So here's my number line here. And because I'm working in quarters, I know that I have to split my number line into 4 equal groups, okay? So if I split it at 6, that gives me 2 equal groups, and then half of 6 is 3. So there I am going to, actually I want the other marker back so that you can see. So as I was saying, splitting into 4 equal groups, okay? So 6 gives me 2 equal groups. 3 gives me 4 equal groups. So I'm going to have a group of 3 here, group of 3 there, group of 3 there, and a group of 3 there. So I have 3 here, 3, 3, and 3. Now I want to know what 3 out of the 4 groups is. So if I add these 3 together here, that gets 9. That's a horrible 9. Okay, so then I know again that 3/4 times 12 is 9. So maybe that makes sense to you guys. I don't know. I don't know if I articulate it properly or not, but those are just kind of the ways that I would go about solving a problem like that. The first one initially I would do is make them into fractions, just so that it's easier to work with from there. But both methods work, so whatever you find easier. So this is the week before spring break. So next week is technically your spring break. So take some time and enjoy the time off. Do things around the house that you maybe wouldn't do. Help your family clean. I would love if my kids helped clean my house, but they're still pretty young, so chances of that happening are pretty slim. But anyway, stay safe, stay healthy, stay active. See you around.
Hi everybody, hope you're staying safe at home. Just finished my fitness workout for the day, and now I'm going to try one of Miss Maskew's mental math problems. Here to help today is my dog Finn. Finn, down, down, good girl, wait for the problem. Okay, I chose this problem because it involves travel. So here's the question. A plane traveled 2,700 kilometers in 9 hours. And the question is, how far did it travel in 1 hour? The way that I would approach this is I have to get my hours down to 1 hour. So I would divide 9 hours by 9 to make it 1 hour. And because I divided the hours by 9 to figure out the kilometers per hour, I also have to divide the kilometers by 9. So see if you can do this in your head. I'm going to try to do it in my head myself. So 9 goes into 2, doesn't go in, but it does go into 27. So 27 divided by 9 is 3, and 0 divided by 9 is 0, and 0 divided by 9 is 0. So I think the answer is 300 kilometers in 1 hour. Hope that's the answer you got as well. Now next week's spring break, so remember, keep doing your math, keep reading, and of course, stay active and safe. We'll see you after that.
Math with Maskiws. Math with Maskiws. I get to be on Math with Maskiws. This is great. Here's my question. I think it's number 5. Something like, what two whole numbers is the square root of 14 between? Well, it's got to be 13 and 15, right? Wrong. It's not 13 and 15. That's what it would be if it was whole numbers. But the square root of 14 is just a number, and it's sandwiched between these other ones. The square root of 9 is a perfect square. 16 is also a perfect square. So if I square root those bad boys, the answer is 3 and 4. So I'm thinking the square root of 14 is somewhere between 3 and 4. No, not 34, Mr. Mac. 3 and 4.
Stretch of my imagination do I believe you've all come here to hear me lecture, or rather to ascertain the identity of the mystery math magician. So without further ado, come forward, silent rogue, and receive thy prize. Well, I'm sorry to disappoint my spectators, but it seems there will be no unmasking here today. However, my colleagues and I have conferred, and there is a problem on the board right now that took us more than 2 years to prove. So let this be said. The gauntlet has been thrown down, but the faculty have answered, and answered with vigor.
Looks right. Right. Hey guys, I'm Mr. Math with Maskiws. Anyways, The question here is write 0.54% as a decimal number. Remember that a percent is always out of 100. Okay, so if you ever forget that, remember a percent is always out of 100. So when you get a percentage, you always divide by 100 to get the decimal form. So in this case, 0.5. I never put the 0. It's just me. Divide that by 100. And 2 zeros, decimal spot goes backwards twice. So 0.2 zeros, 2 zeros. 0.0054 is your decimal. Booyah!
All right, today we're going to take a look at how to go back and forth between a table of values and take that information and put it on a graph. So it seems kind of crazy to think that we could put these numbers on a graph, but we can, because what these make here, our A and our B coordinates, actually make coordinates that allow us to make a graph. Now in this particular graph, you see that there's actually a point at 0, 0. You will see that that doesn't happen all the time, and if there isn't one at 0, 0, don't put one there. If you do and it's not supposed to be, then your line won't be straight and we will not have a linear relation. But my first point here is at 0, 0. That's my first coordinate. The next one is at 1, 3. That's the next coordinate. That's this point right here. Then our next ordered pair is 2, 6, 3, 9, and 4, 12. So I'm just quickly going to plot all of these on our graph. We have 2, 6, 3, 9, 3, 9 is right here, and 4, look at that, we're missing a couple numbers here. 4, 12. Now if I take a look there, I see that everything is in a perfect line. And you're asking yourself, should I join those points together? What do you think, Scott? Should I join them?
Yeah.
Aw, you had a 50-50 chance of
Darn
getting
it.
it right. No, we do not join the points on a linear relation.
Oof.
So now we've got our linear relation. Perfect. Down below there, you've got a spot that says, look at the graph. Describe how to get from one point to the next. So starting at 0, 0, we're moving 1 point horizontal, okay, 1 unit horizontal, and for every one I move horizontal, I'm moving 3 vertical. So if I look at the table of values, I'm figuring out how to get from A to B each time. Always trying to figure out how to get from A to B. And I look here and I see, wait a minute, if I multiply by 3 each time, I will get there. So I can use that to help me find my expression. Times 3. Mark, do you remember how I make an expression out of times 3?
3x.
Perfect. So my expression is 3x, which means 3 times x, or in this case, A will give us B. We're back with another example here. So this time, I've got x and y instead of A and B. And we have 1, 5, 2, 10, 3, 15, 4, 20. So we can actually turn those into our ordered pairs in the chart that you've got there. So we've got 1, 5, 2, 10, 3, 15, and 4, 20 for our ordered pairs. So I'm just going to plot those on my graph. 1, 5, 2, 10, 3, 15, 4, 20. Again, we notice that we don't have a point at 0. So if I'm looking here trying to figure out how to get from X to Y, Mark, how would you get from X to Y here?
You would times it by 5.
Times 5. All right.
5x.
So that would be 5x. And what we see is that when we move from one point to the next, we move 1 unit horizontal, we move 5 units up, therefore we have 5x as our expression. All right, another special guest star. Mark's going to help us today. Mark, what we're trying to do with this one is we're trying to figure out which one of these two is a linear relation. So we're actually going to graph them to see if we can figure out which one has the points in a straight line. So we'll go on the one on the left first. So I'll zoom in here a little bit. Can you put a point at 2, 3 for us? The coordinates 2, 3. All right, that was an easy one. How about 4, 7? Okay, there's 4, 7. Where would 6, 11 be? 6, 11 and 8, 15. 8, 15. All right. Does that line look like it's going up in a straight line? Yeah, it sure does. It looks pretty straight to me. Let's give the other one a try here. Let's put a point at 1, 1. Okay, there's 1, 1. How about 2, 4? 3, 7? Okay, and 4, 8. That looks like 4, 10. Can you get that one at 4, 8?
Yep. My bad.
All right. What do we notice about what happened right at the end there when we put that point at 4, 8? Is it still in a straight line?
No, not really.
No, all of a sudden things are not in a straight line anymore. So we're going to go back to our table of values and we're going to try and figure out what happened. So if we look at the top row there, 2, 4, 6, 8, what's the pattern, Mark?
It's going up by 2.
All right, so each one is going up by 2. When we look at 3, 7, 11, 15, what is happening, Mark? 3, 7, 11, 15.
It's adding by 3.
3, 7, 11, 15. Are you sure that's 3?
No.
What is it increasing
4.
by? Okay, so it's going up by 4 each time. So that's why this one's linear. Let's look at the other one now. 1, 2, 3, 4. What's it increasing by each time?
1.
It's increasing by 1. Now, if we look at the y-axis, 1, 4, 7, 8. What do we notice?
It's going up by 3.
And then what happens at the end?
It goes up by 1.
It only goes up by 1. Now, what this is going to mean is that I could ask you guys to sit here all day trying to figure out what the pattern is for that second one, but you would never be able to figure it out. And that is because it is not a linear relation. So if we look at the bottom of your page, it says the difference in the y coordinates is the same. The relation is linear. The difference in the n coordinates is not the same. The relation is not. Okay, I'm not entirely sure that Scott knew how difficult this question was when he signed up to try it, but that's okay. We'll give him a shot here. All right, Scott. So the first thing we got to do is get that chart filled in where it says number of hours, which is going to be n. Right? And then we've got Sam's pay, which is going to be represented by the variable P for pay. All right, so if Sam works 1 hour, I'm not sure if Sam's a he or a she, the pay would be $7. For 2 hours, it's $14. For 3 hours, $21. Scott, for 4 hours, how much is Sam going to get paid?
$28.
Right on. Can you write that down? You write down $28. And maybe while you're there, you can do 5 hours too.
Okay, 5 hours would for sure be 35. Okay, kids?
Scott, can you tell me how you knew that it was $28 and $35?
Because over here they were adding it up by 1, And over here, they were adding it up by 7.
Oh, so you just kept going up by 7 all the time. Right
Yeah.
on. Well, let's see if you can put those numbers in a graph for us. Can you label where the point 17 would be?
Right. That would be
Right there,
here, Mrs.
okay.
Maskew.
How about 214?
Right here, Mrs. Maskew.
321.
Right here, Mrs. Maskew.
All right, now we got the graph finished, so it's time for us to try and find the relationship between the number of hours and Sam's pay. So if we zero in here a little bit, Scott, can you possibly tell us how we can get from 1 to 7, 2 to 14? How do we get from the number of hours to the pay?
Well, that's easy. You go down here. 7 N.
Good.
Then
So 7 times the number of hours will tell us what Sam's pay is. Excellent. So the next question in your book asks you, what if Sam works for 9 hours? So what do you do now, Scott, if Sam works for 9 hours?
now you do this multiplication, kids.
7 times 9. What is 7 times 9, Scott?
Well, I think you learned this in about first grade. That would obviously equal 63
Excellent. 63 what, Scott?
of this.
Good. Make sure you always have units. So that is $63 for 9 hours of pay. Thank you.